Hi, Assalamualaikum. Welcome to Engineering Statistics Ssce 2119 Section 22. So today, my groupmate and I would like to present about our group project, which is about the production of Lajakkuruih tablet. So first thing first, let me introduce you guys with my groupmate, which is who is Farah Ilya, Aisyah Zukri, Eva Clays, Afika Yunus, and myself, Masabila binti Zaidan. So let me straight to the main point where this project is to monitor the quality of tablet production of Lajakkuruih tablet. So it consists 200 samples for each Lajakkuruih tablet and also covering 3 shifts, which is morning, evening and night. So all the data also consists about its own tensile strength, weight and relative density. So my group has chosen pin Lajakkuruih L as our reference.
Assalamualaikum, I am Afika. So for now, I'll be explaining question A. So based on question A, we need to summarize the data based on this data of Lajakkuruih L. So in this table, we have categorized them the shift into evening, morning and night. So from here, we can know the count of weight for each shift. And then from this data of Lajakkuruih L, given the weight, relative density and tensile strength. So we categorize them into each shift. And so from there we can get the sum of weight, sum of relative density and sum of tensile strength. And we can calculate the grand total. So from this table, we can know the highest of the sum of weight will be in the evening, and the relative density, the highest will be in the evening as well, and the tensile strength, the highest will be in the evening as well. So from this table, we can simulate the graph as shown here, which is the shift versus the values of the characteristic. This table we can read through the short notes, and so that we can refer for which characteristic and for which shift based on shift. And then next we have next table we have the range of weight, and this is the count of weight for this range of weight. So from here also we can simulate the graph. So the graph, it is much easier to see which range of weight is the highest. So from here we can conclude that the 341.93 to 351.93 is the highest range of weight. That's all for me. Thank you.
Hello everyone, my name is Eva Clarista binti Arjisli, and I'm going to explain to you guys the part B of this Lajakkuruih tablet production analysis. So in this part B, we have to do a test which to show Lajakkuruih either it follows the normal distribution or not. So in this process, we will use the goodness of fit test to prove and to get the significant evidence either the Lajakkuruih tablet follow normal distribution or not. So the hypothesis statement that we're going to have here is H0. The data follow normal distribution with mean 350 mg and standard deviation 14 mg. And the HI is the data does not follow normal distribution with mean 350 mg and standard deviation 14 mg. So what we are going to do first thing is by using the previous range, which is from these row labels, we will get the frequency of each row labels, and when we sum up, the frequency will finally equal to 1. So the next thing, what we're going to do is we will do this goodness of fit table, which will include the observed value, the expected value, and the observed minus expected value, and we square it up, then we divide it to the expected value. We can get the observed value from this count of weight, and to get the expected value, we have to multiply the observed value with the frequency of each range. Then we will get the expected value for each observed value. Okay. Next thing is we're going to calculate the observed value minus the expected value. We square it up, then we divide it by the expected value, and we will get these values. But then if we see from this table, the expected value is less than 5. So we have to merge the data, so we will get this value. So from this value, we'll get 4 datas, and the most important thing is the summations of these datas. So for the expected value, we get 40.8978, and for the observed value minus expected value, when we square it up, then divide by the expected value, we will get 719.139699197. So if we look at the rejection rule, we know that the point of rejection rule is 7.8147. So beyond this is the reject H0 region, and before this is the accept H0 region. So since our chi-squared test is 719.1369197 is larger than 7.8147, so we can conclude that we will reject H0. So as a conclusion, the data does not follow normal distribution with mean 350 mg and standard deviation 14 mg.
For question C, let us if there is any significant difference between tablet weight from the different shift. For this question, we use ANOVA single format, which is one-way ANOVA in Microsoft Excel. This method is used to investigate is there any significant difference between the tablet weight from three different shifts. First, we have to tabulate the data based on their shift. Second, we have to create a hypothesis statement, which is H0 and H1. H0 represents there is no significant difference between the tablet weight from different shifts. For the H1, it represents there is a significant difference between the weight tablet with the different shift. Okay, this is our ANOVA single factor that we get from the Excel. We use alpha 0.05, which is 5% of significant levels. For the rejection rule, P minus value is larger than alpha, we fail to reject the H0. While if P minus value is less than alpha, we reject H0. For this ANOVA, we get P value is equals to 0.562872151, which is larger value than the alpha. We fail to reject H0, and we conclude that there is no significant difference between the weight and the difference of shift. Thank you.
Assalamualaikum, my name is Aisyah binti Muhammad Zuki. I will explain the problem and the solution in question D for P Lajakkuruih L. So for the question D is required to do regression and correlation analysis. From the question given, we can identify that the relative density is a dependent, meanwhile the tensile strength is a independent. From the dependent and independent, variable x and y are known. This test also to determine the correlation or the relationship between the tensile strength and the relative density is linear or non-linear. This test also to determine the 95% confident in linear relationship between the tensile strength and the relative density. In summary, we can obtain the value of sample correlation coefficient directly from multiple R or by taking the R square root of R square. The quantity of R square is called the coefficient of determination, and it is often to use the adequacy of a regression model. The sign of R, positive or negative, will depend on the estimation of beta. For example, if beta is negative, the value of R will be also negative after computing the square root of R square. From the ANOVA table, the table is quite similar in question B, but the arrangement is a bit different. From this data, we obtain the residual value, which means it refers to the error in the sample data, but this difference will not affect the final result of a correct analysis. Next, the F value in the ANOVA table is the value of the test statistic. Meanwhile, the significant F is the probability of F variable being more than the test statistic. Based on the P Lajakkuruih L table, the significant F is this. In order to make a decision the significance of the regression, we can compare the significant F with the chosen significant level alpha. For our cases, we had choose 95% confidence interval. The value of significant F is this one, which is much lower than the alpha 0.05. Thus, we reject H0 and we can clarify that the data in P Lajakkuruih L table provide strong evidence on the existence of linearity in the regression model. Next, for the table that we get is the estimation of the unknown regression coefficient. For the data in P Lajakkuruih L table, the intercept and the relative density are represented in the alpha and beta, respectively. Therefore, the alpha is negative 0.228853993 and the alpha is 0.083139057. To check the value of the significance of alpha and beta is by compare the p-value for the alpha beta by rows. For this table, the p-value for beta is this, which is much lower than the chosen significant level 0.05, which implies that the linearity between two variables does exist. Estimation that we get from the Excel for the gradient M is 0.083139057 and the standard error is 0.03525507 and the intercept C value is negative 0.228853993 and the standard error is 0.30970986. Last but not least, the scatter diagram are obtained to display the paired measurement and the fitted value. The straight line refers to the fitted regression line in the data. So, we can obtain this equation. So, for the tablets that show a low of the relative density, which is 68%, 74.3%, 80.1%, shows this value of tensile strength. So for the conclusion that we can make is the linear regression model is a valid model to predict the test result of the tensile strength of the P Lajakkuruih L based on its relative density with up to 95% accuracy. Thank you.